hopefully. Okay, here we are. We are recording. This is the RD gel, Restriction Digest Gel, for periods 3 and 12. But it's the same process for all the periods. So the first thing I did was make maps. This is period 3. You can see marker and then T1, T2, T3, T4. And then on the bottom, marker T5, T6. There's a top and the bottom because the combs for my gels don't have enough slots, so I have to make 2. You can see one of the gels is the top and there's a bottom. And so I have to do this because I don't have big enough combs to make enough wells in the gel. There's only so many wells. So for period 3, I put 8 on top and 10 on top and 8 on the bottom. Okay. And here's period 12, you guys out there, period 12 map. Same thing, 4 on top, 2 on the bottom, T1, T2, T3, T4 on top, and T5, T6 on the bottom. And you guys have the same gel. Yours is a bit longer because I ran out of other little boxes, but it doesn't matter. Really, it doesn't matter that much. Okay, the first thing we have to do is we have to cut out the gel from the black bumpers, and I'm going to surgically remove that by just slicing it out. When I do this, I have to be super careful not to cut into the actual wells. Now I'm wearing gloves because this gel has a chemical in it that's a known mutagen, and that mutagen is ethidium bromide. It's a mutagen, don't touch. Ethidium bromide. So see, I sliced it away so I can pull the bumper away. I can pull the bumper away this way, and the gel will not pull away from the bumper, the black bumper. So now I have the combs. Here's a little pro tip. Don't ever just pull these combs out of the gel because you could break the gel. And so to get them out, we nestle the tray in the box. We fill it with the salt buffer solution, the tris acetate, EDTA, pH buffer / salt solution that conducts electricity. And then I could push the box down and the combs just pop out, which is nice. And you can see the wells in the gel, which is nice. The wells on top and the wells on the bottom. Let's do the same thing for period 12. I'm going to fill their box first with buffer salt aqueous solution that conducts electricity. Let me surgically remove the bumper from the gel. This is how I get to be, I play surgeon this way. Okay, and I just pull those away. Nice, nothing broke. See that? Nice clean demarcation, nothing broke. Nice, and then I just sink the tray in the box. And I just wiggle it just a little bit, wiggle the comb, and it should pop out. This one's a little stubborn, but it's in there. It came out. All right. All right. Blink. All right. So let's load these. Now I can move them now because there's no DNA in them. But once I put DNA in these things, I better not move them. I'd be smart not to move them once I do that. Now, organization is key. Organization is so important with this biosciences. I'm sure you guys know. If you're not organized, you will make errors. Ask me how I know. All right. So I have my tubes here, my UD tubes. UD, right? So one of these is period 12, one of these is period 3. And I can see this is period 12. So this is you guys, period 3. P3, T6 down here, and P3, T1. So P3, T1 is right here. UD, 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 UD. So I'm going to put those way over here. Get my box ready. Is this a good view? Let's see, I'll go even closer. Maybe you can see it that way. Okay. Get the tip first. I'm going to load the ladder, DNA ladder. So the ladder is going to go in the leftmost lane. Yeah, you can kind of see it actually. I'm pretty amazed. These cameras are good. And I'm going to put the ladder in the leftmost lane of the bottom gel. Now, ladders are nice and easy to load, like any load here, because they're blue. And the color difference is really easy to see. All right, so double check. Here we go. P3T1U. P3T1U. Boom. Done. P3T1D. Done. New tip. P3T2. U. It's very redundant here. It's the same thing over and over again. If you get it, you can kind of tune out for a moment and do something else. D, P3T2D if you want, or just keep watching. It's fine too. But it's the same process over and over again. Say there's a load right there. You can see it. This is U for P3T3. And here's the D for T3. Get rid of that tip. Get a new tip. Here's the U. I'll try to do it in the camera. For T4. That clicking sound you hear is me getting a new tip. And here's T4D. T4D. Look at that. I think you can see all those that blue wall. Those are successful loads. I'm pretty happy. So let's do T5U. T5U. T5D. I'm loading 20. That's not super important, but I'm loading 20 like everything. T6U. And T6D. Nice. Now, I was only able to do that because of my organization. Organization is so important in science, to have everything labeled and ready to go into the line. I'm sure you guys know that in your own lives. It's important. So I'm going to plug in the leads. The red is the positive lead. The black is the negative lead. The red is actually the anode. That's where the negative ions flow towards. And the black is the cathode, which is negative. That's where the positive ions flow towards. It's actually reversed. Anodes are actually positive and cathodes are actually negative, whereas cations are positive and anions are negative. DNA is an anion. It runs towards the anode, the red. DNA runs towards the anode, the red. So how do I know this is working? If I look at the, turn it on, that helps. If I look at the gel box, I can see bubbles. And the bubbles, I'll try to show them to you. The bubbles are electrolysis of water at the leads. Water is electrolyzing. Electricity is flowing through water molecules, turning the water into hydrogen gas and oxygen gas. Ergo, the bubbles. The bubbles. I don't know if you guys can see it. I can barely see it, so you can probably maybe see it. I don't know. All right, so let's do period 12. We can't ignore them, can we? No, we cannot. So let's see. Better way to visualize this. I'm going to move you guys so you can see it. Hopefully better. Or different, at least. Here's period 12. This is P3. Okay. This is P12. P12. We have tables 1 through 4 on top. And other tables on the bottom. So let's load the ladder first. I'm using my ladder, not Rutgers' ladder. I ran out of their ladder, to be honest. And I have a fair amount of this ladder. This ladder is not as good, but it's bright, which is nice. It's a PCR ladder. All right, so there's a ladder on top and a ladder on the bottom. It'll work. We'll be able to size up everything we need, I think. All right, new tip. All right, let's do it. Organizations are critical here. We have P12T1 and P12T6, UD, all the way down. So here's P12T1U. Wow, that's a lot. I think I gave them too much loading die. That's okay. I'll load all of it. What the heck, right? I'll load all of it. Can't hurt. This is D for T1. P12T1D labeled. My handwriting is not the best, but it works. P12D1 labeled. Okay. That tapping sound you hear is me getting a new tip, so you should hear that between every load. Tap, tap, tappy. P12T2. U. P12T2U. Cool, you can see the little blue loads appearing. P12T2D. P12T2D. P12T3, U. P12T3D. P12T4, U. P12T4D. Bottom gel now. Last two, P12T5U on the bottom. I better not bump one of these and knock it over. That'd be bad. P12T5D. A little extra. I'll go back and use the same tip, same well. Two more, P12T5U. And lastly, the last load we'll do for the Walksman program, P12T6. Did I say 5? 6, I meant 6D. That's a D tube, P12T6. Done. D for done. Done. All right. Wow, that was a lot. So let's put the cap on. Make sure the leads line up, black to black, red to red. Black's the anode, red's the cathode, just like on a car battery or your household current. Let's check for electrolysis of water at the leads. And I can see electrolysis of water at the leads. So you can see, I think you can see, hopefully, the loads came out nice. The loads came out nice. Let's look at P1. This is from this morning. So yeah, I did this like a half hour ago, and they're already moving nicely through the agarose field, the electrophoretic field. That is the RD gel. So I'm going to pause the video here because there's nothing more we can do. What I'll do when I'm done with this is I'll pull these out. I'll take pictures of them today, and then I'll put them in the classroom postings, and then we'll mock them up. But this is RD, P12, RD, P12, RD, P3, RD, P3. And this is RD, P1, top, RD, P1, bottom, RD, P9, top, RD, P9, bottom. All right, guys, that's it. It's been a pleasure. I'm going to pause the video. Stop.